All right, so I think this is recording. Let's take a look at these three equations. These equations are referred to as quadratic in form. Technically, they're not quadratic equations, but through a change of variable, we can write them as a quadratic equation. So let me illustrate what I mean by that. In problem number 1 here, I'm going to let u equal x squared. So everywhere that I see an x squared, I'm going to replace it with the variable u. If I square both sides of this, if I square u, then I have to square x squared, which is x to the fourth. So instead of writing x to the fourth minus 13x squared, I replace x to the fourth with u squared. And instead of writing x squared, I replace x squared with u. And now, through a change of variable, I have an equation that is a quadratic equation. I can solve this by, in this case, I'm going to solve it by factoring, but I could also solve it by the quadratic formula. Since my leading coefficient is a 1, it's hopefully easy for you to see to come up with two numbers that multiply together to give us 36, but add together to give us negative 13, a negative 9, minus 9, and minus 4 do the trick. And now to solve this equation, we see that we have that this splits into two equations by the product theorem, and I have u is equal to 9 or u is equal to 4. But I haven't finished the problem. See, I've told you what u is, but the original problem had x, and we want to know what x is. So we change it back to the variable x. I have a u here is equal to 9, so I replace u with x squared. So if x squared is equal to 9, that's going to give me a solution of positive or negative 3. And over here, if x squared is equal to 4, that's going to give me solutions of x is positive or negative 2. So I had a fourth degree equation, and I came up with 4 solutions, but I did it through a technique that is referred to as a change of variable. Like I say, you will see that technique quite a bit if you ever take a calculus class. Oops. All right, so let's take a look at this next one here. We always start with that, if it's in standard form, with this middle term. And for it to be quadratic in form, notice that the x squared, the 2, was half of 4. Let's actually write this in exponential form. I've got 3x, and I'm going to emphasize that that's to the first power, and the square root of x can be rewritten as x to the 1/2 power. So whenever the exponent here is half of the 2 was half of 4, the 1/2 is half of 1, we say that that's quadratic in form. So I'm going to do my change of variable and let u equal this x to the 1/2 power. And that's what you always do is you let u equal that middle term, that middle variable. Now, if I square both sides of this equation, then u squared is just equal to x, because when you have x to the 1/2 power and you square it, when you have a power raised to a power, you multiply those exponents, and that's just x. All right, so I'm going to rewrite this equation, but I'm going to rewrite it in terms of u. So I have 3 times x, but I'm going to replace the x with u squared. And then I have plus 8 times x to the 1/2 power, but x to the 1/2 power I'm going to replace with u. And so now I have a quadratic equation, and I can solve it using our x method. Take the first term times the last term, and that's negative 9u squared. The middle term is 8u. Two numbers would multiply together to give us the top value, that add together to give us the bottom value. And then if we put this in the form of a table, along my diagonal, I take the first term and the last term of my original equation, and along the other diagonal, the values I found by trial and error in the x. And then I factor horizontally and vertically. Let's just make that a 3. And we'll make this a -1. We'll make this a u and a 3u. And we can see that 1u times 3u is 3u squared, that 3 times 3u is 9u, 3 times -1 is -3, and 1u times -1. So everything looks good there. And then if I come over, I have u plus 3 times 3u minus 1. That equals 0. This splits into two equations. And this solves to u is -3, and this in 2 steps. Add 1 and divide by 3. Getting a little bit used to this software. All right, so now I've solved for u, but remember my original variable was x. So I need to come in and replace the u with x to the 1/2 power. The x to the 1/2 power will never be a negative value. The square root of x is never going to be negative. That's a principal square root, and by definition, it's always 0 or positive. So this solution is extraneous. This isn't going to give me an answer here. But here, if I replace u with x to the 1/2 power is equal to 1/3. If we square both sides, remember that if you have a power to a power, you multiply the exponents. So if we square the left-hand side to balance the equation, we have to square the right-hand side. Half of 2 is 1, so you have x to the first power is equal to 1/9. And that's our only solution for this equation. All right. Now, I think I'll have enough room over here that I won't have to shrink that up. Let's change colors. All right, so again, I want to do a change of variable. My middle term there is x to the 1/3 power, so I'm going to let u equal x to the 1/3 power. And if I square both sides of this equation, then I'll have u squared is equal to x. And remember, a power raised to a power, you multiply the exponents. 1/3 times 2 is 2/3. So this first term, x to the 2/3, is replaced with u squared. And this middle term, x to the 1/3 power, is replaced with u. And now it looks more familiar. You're more familiar. The whole idea is to write this in such a way that it's easier for you to solve. The x to the 2/3 minus x to the 1/3, you've probably never solved an equation like that. But here you definitely have solved a quadratic equation like this, either through the quadratic formula or through factoring. And here with the leading coefficient of 1, it's easy to see that this factors to u minus 3 and u plus 2. And this splits into two equations where u minus 3 is 0, or that u plus 2 is equal to 0. So we've easily solved this for u, but we want to solve it for x. So we replace u with x to the 1/3 power. And if I raise both sides of this equation to the third power, I get x, and 3 to the third power is 27. And over here, if I have x to the 1/3 is equal to -2, if I raise both, see, this is an odd index. This is not the same as this was a square root, an even root, where it had to be positive. This is an odd root. This is the cubed root of 3. If I raise both sides of this to the third power, then I get that x is equal to -8. So those are my two solutions there. So it's probably going to take a little bit longer practice and stuff for you to get used to this type of a problem. But the middle portion of this problem, where once you've changed the variable and made it a quadratic, that part you should be very familiar with. It's the initial substitution and then the substitution back to the original variable that you're going to have to get used to. And you get used to that through practice. So continue doing more and more of these problems. Ask me questions as necessary. I hope this helps, and I'll talk to you later. Bye.